The most distant star known to science, which had just been recently discovered by researchers using the Hubble Space Telescope, has been seen by the James Webb Space Telescope. The James Webb Telescope just discovered one of the first and most distant stars in the universe. So which star is the first and most distant in our universe? In this video, we are going to learn more about it and find out. Welcome back to Space Unearthed. The star, called Earendel, was found through gravitational lensing in a Hubble Space Telescope wide-field photograph. It was named after a figure in J.R.R. Tolkien's Lord of the Rings prequel, The Silmarillion. It may be difficult to spot the new star in the new James Webb Telescope image, which was posted on Twitter on Tuesday, August 2nd, by a group of astronomers using the account Cosmic Spring JWST. There is some direction in the original Hubble image on where to look through the cutout that is zoomed in. Earendel is essentially the little white dot that lies beneath a group of far-off galaxies. You can locate the elusive Earendel by comparing the Hubble image with one taken by Webb. The phenomenon makes use of the way that extremely enormous objects, such as galaxy clusters or supermassive black holes, bend the light coming from behind them. When light encounters such a body, it acts as though it were to be doing so through a telescope's lens, getting distorted but also magnified. Therefore, gravitational lensing increases the field of view of telescopes like Hubble and Webb, allowing them to see further and in more detail. Webb was made to observe the very earliest galaxies that emerged in the newborn cosmos in the first hundreds of millions of years after the Big Bang, following the period of darkness. However, astronomers believed that it would not be feasible to observe individual stars from this initial generation of then-forming suns. Gravitational lensing might actually even allow them to get a close-up look inside those early star clusters. Even though Earendel, also known as WHL0137LS, is in the Cetus constellation, it is not visible if you look up into the night sky, since even gravitational lensing isn't that strong. The Sparkler Galaxy. The JWST's first deep field image showed a stunning assortment of galaxies and galactic clusters that distort as a result of gravitational lensing. Albert Einstein's general theory of relativity made the first prediction about gravitational lensing in 1915, and since then it has helped astronomers observe the universe more effectively. According to general relativity, massive things bend space-time. Imagine putting massive balls on a stretched rubber sheet. The bigger the mass, the more curvature there would be in the rubber sheet. Gravitational lensing results when the light from far-off brilliant objects bends around a large object like a galaxy or a galaxy cluster that is situated between the emitting and receiving object. In other words, gravitational lensing intensifies the light from far-off objects, allowing us to see very far-off objects even though they are very far away. The Sparkler Galaxy is a galaxy 9 billion light-years from Earth that has been the subject of research by a group of Canadian astronomers because the compact objects that surround it appear as tiny, vivid yellow-red specks. The Sparkler Galaxy's peculiar, stretched shape is a result of the gravitational lens. In the JWST deep field view, the same effect is responsible for the appearance of many encircling clusters at various locations. The nearby objects that gave rise to the moniker are of great scientific significance, since they might be the farthest globular star clusters that astronomers have yet discovered. Globular star clusters are groups of old stars from the early days of a galaxy, so they might hold on to information on the beginnings of galactic formation, expansion, and history. On the one hand, we have the James Webb Deep Field, and in the center left section, you can see a galaxy warped by a gravitational lens, but around it are 12 unexplained dots. This is the team's discovery. The 12 spots surrounding the Sparkler Galaxy cannot be seen with the Hubble telescope, but they can be viewed with the James Webb. The Canadian NIR-ISS Unbiased Cluster Survey team examined the 12 compact objects that surrounded the Sparkler Galaxy and discovered that 5 of them are globular clusters. The globular clusters may also be among the earliest ever observed, possibly existing at the moment the universe first started to produce stars. Before James Webb, it was difficult to date the initial stars in early distant galaxies using such far-off globular clusters. As a result, the scientific community has made a novel and fascinating finding. About 150 globular clusters can be seen in the Milky Way, although their ages are yet unknown. So you guys have almost heard everything about this. Do you think there are more stars that we need to find out? Do you think those stars serve any purpose? Since scientists can see more distant clusters, such as the Sparkler Galaxy, as they were 9 billion years ago, when the cluster was so much younger and the universe was really only 4.5 billion years old, it's much simpler to date them. Are all these stars the first to emerge in the cosmos as we know it? It would be premature to say that we have found the oldest stars in the cosmos yet. For the time being, all that is left to do is to continue examining the photographs that the James Webb Telescope has provided. The next finding is the spiral galaxy IC 5332. This is the spiral galaxy IC 5332. The views on the left and right are from the Hubble and James Webb Space Telescopes respectively. The photographs, especially when their data is combined, demonstrate the potent capabilities offered by both of the world's best space telescopes. With a diameter of roughly 66,000 light-years and a distance from Earth of more than 29 million light-years, the galaxy IC 5332 is 1/3 smaller than the Milky Way. It stands out because it almost precisely faces the Earth, allowing us to marvel at the symmetrical movement of its spiral arms. Using this mid-infrared instrument, the James Webb studied this galaxy. This one is the first device to reliably produce mid-infrared images as sharp as Hubble's at shorter wavelengths. Infrared radiation is far less probable than ultraviolet and visible light to be dispersed by interstellar dust. Since most of the ultraviolet and visible light from the galaxy has been unable to pass through these regions, dusty regions may be easily seen in the Hubble image as the darkest ones. However, because the galaxy's mid-infrared light has been able to travel through them, those very same dusty regions are no longer dark in Webb's image. Because some stars shine brightly in the ultraviolet, visible, and infrared spectrums respectively, it is possible to see different stars in two photos. It's astounding how drastically different the same galaxy appears when viewed through two different telescopes. Can you imagine what we can see when we look at the entire universe if this can be done by merely looking at a galaxy? Hubble and James Webb worked together on the DART mission. Recently, NASA used the DART mission to conduct an experiment to deflect an asteroid. The two most potent space telescopes at the time, Hubble and the James Webb, were put to the test by NASA scientists and engineers. For the first time, Webb and Hubble were employed to study the same astronomical target concurrently, yielding original photographs from NASA's Double Asteroid Redirection Test, or DART, project. On September 27, 2022, at 0114 CEST, DART purposefully collided with the asteroid Dimorphos, the tiny moon of the Didymos double asteroid system. It was the first time an asteroid had ever been deflected by altering its orbit via kinetic impact by a spacecraft. According to measurements, DART, a test to protect the Earth from the potential risks of asteroids or comets, has been an unparalleled success. For every telescope, the observations represent more than a key operational milestone. By merging the capabilities of these operations, scientists can investigate important scientific problems about the makeup and development of our solar system. This will help determine whether it ejected predominantly small material or many huge chunks of dust. The combination of these data will enable scientists to comprehend better how an asteroid's orbit can be altered by a kinetic collision. An encounter with James Webb prior to the collision, Webb spotted the impact position and made more observations during the following few hours. Do you want to know more about the James Webb Space Telescope? Let us know in the comment section below, and thank you very much for joining us. Don't forget to subscribe, like, and turn the bell icon on. We'll see you in the next video.